Hi guys, so we have an O-level past paper question from the year 2016. The session is May-June. This is question number 4. This question is from the topic of angles, similarity and congruence. So let's get into it. The question says AB has sides AB which is equal to 8 centimeters, AC which is equal to 7 centimeters and BC which is equal to 12 centimeters. Use a ruler and compasses to construct triangle ABC. Side AB has been drawn for you. So that means this side over here, this is going to be 8 centimeters. And if this is 8 centimeters, we need to construct another line that is AC, which is going to be 7 centimeters. So if we construct AC that is going to be 7 centimeters, first we need to open our compasses to 7 centimeters. Let's have a look at that. So 7 centimeters is roughly going to be somewhere about here. Okay, so we draw an arc from this point, that is A. I hope this is visible, like this. Okay, I made a mistake over here. Let's try it again. So we have our scale over here and we draw an arc that goes like this. If I erase this and draw another arc that is going to be 7 centimeters away from this point, just like this. The next thing is that they've asked us to draw BC, which is going to be 12 centimeters. So we open our compass from 0 all the way to 12 centimeters like this. And then from B, we put our compass over here. I hope this point is visible. And we draw an arc like this. This is the other arc that is going to be 12 centimeters away from B. So then we connect these 2 points. We connect them by a straight line. We connect this point with B over here. I hope this is visible. And then we connect this point with A over here, just like this. And we call this point C. The next part says measure angle BAC right here. So we have to measure this angle right here. How do we measure that? We take our D, we put it over here, and we look at it, and the angle that comes out is going to be, let's have a look at it first. The angle that comes out is going to be roughly about 110 degrees. So we write our answer over here. This is going to be 110 degrees. The next part says calculate the interior angle. I hope this part is visible. Calculate the interior angle of a regular 12-sided polygon. In order to find the interior angle of a regular 12-sided polygon on any polygon, the formula that you use is n minus 2 times 180 over n. In this case, n is going to be 12. So it is going to be 12 minus 2 times 180 divided by 12. Let's plug this into the calculator. 12 minus 2 times 180 divided by 12, this gives us, this should give us 10 times 180, and then divide this by 12, this gives us 150, and that is equal to n. The interior angle is going to be 150 degrees. Okay, let's move on. The next part of the question says, the diagram shows a hexagon with 2 parallel sides. I hope this is visible. The diagram shows a hexagon with 2 parallel sides and 1 horizontal line of symmetry. Calculate angle P. We have to calculate this angle right here. How do we calculate that? The easiest way, and since this is a 1-mark question, the easiest way of going about this is, first, if you draw a vertical line connecting these 2 points. Okay, so this angle right here is 125 degrees, and the question says with exactly 1 horizontal line of symmetry. That means the line of symmetry goes through the shape from the center. If it goes through the shape from the center, that means every angle that is on the top is also present at the bottom. So this is also going to be 125 degrees. And since this is Q, this angle is also going to be Q degrees. And this angle is going to be 360 minus P. Okay, so we talk about angle P over here. How do we find that? So if this is a straight line, if this is a vertical line that we just drew, then this angle right here, if this is visible, this angle right here is going to be 90 degrees. If we subtract 90 degrees, we will get this angle that's over here, and whatever we get, that is also going to be the same over here. So let's do that. First we do 125 minus 90. When we do that, we get 35 degrees. When we have 35 degrees, since there are two 35 degrees, we do 35 plus p. This should be equal to 180 degrees. And then what do? We subtract 180 minus 35 and this should be equal to p. So basically 35 plus 35 is 70, 180 minus 70 is 110 degrees. So our answer over here is 110 degrees. Okay, let's move on. The next part says calculate Q. Q is the angle over here. Okay, and it is also present over here. Since we already have the value of P, which is 110 degrees, there are 6 sides to this shape. That means the internal angle, to calculate the internal angle of this shape, we would do 6 minus 2 times 180. 6 minus 2 times 180, that is 4 times 180. This gives us 720 degrees. That is the internal angle of this shape. Now what do? We calculate the value of Q by adding all these values and subtracting them from 720 degrees. So basically there's the value of 125. Then there's another value of 125. I hope this is visible. And then there's a value of P, which is 110. Then there's a value of Q, then another Q, and then this little angle over here, which is 360 minus P. So 360 minus 3P, because this is 3P. So 360 minus 3 times 110 should be equal to, and let's put this inside the brackets, should be equal to 720 degrees. I hope this is visible. So to save space, what I'm going to do is I'm going to add the Q's and make them the subject. So 2Q is equal to 720 minus the sum of every other thing that is present over here. First we do 360 minus 3 times 110, and this gives us 30 degrees over here. This is 30 degrees if this is visible. And then we add 30 plus 110 plus 125 plus 125, and this brings us to 390. Then we subtract 390 from 780. This gives us, and let's do it over here, this gives us 2Q is equal to 330, and then you divide 330 by 2 and Q comes out to be 165 degrees. So we write our answer over here. This is going to be 165 degrees. Okay. The last part of the question says trapezium PQRS is similar to trapezium ABCD. AB is parallel to DC and AB is 90 degrees. DC is 2AB and BC is half AB and PQ is 3 over 4 DC. Now since these two triangles are similar, what is going to happen is, first we need to find the length of all these sides over here, because first we need to find the length of DC in terms of x, because the question says that BC is in terms of x, and find the expression in terms of x. So let's find DC first, and then since these two trapezoids are similar, we can apply whatever length we get over here onto the other one. So first AB. How do we find AB? AB is half of BC. So AB is half of BC, and AB then is going to be, since BC is x centimeter over here, AB is going to be half x. Sorry. No, yeah, this is wrong. My mistake. What we are supposed to do is AB is going to be twice of BC. So then you multiply 2 with x over here and AB comes out to be 2x. Okay, since AB is 2x, that means DC is going to be twice of AB. So DC would become 2 times 2x. DC comes out to be 4x. I hope this is visible. If DC is 4x, then over here they say that PQ is equal to 3 over 4 DC, which is 4x. You cancel out the two 4's, you're left with PQ being equal to 3x. Okay, so if PQ over here is 3x, the height is supposed to be half of that. That means 3 over 2x, and SR, this parallel line, is supposed to be double of 3x, which is going to be 6x. Now we use the formula for the area of a trapezoid. How do we do that? So PQRS is equal to half times height, which is 3 over 2x, times the sum of parallel sides, which are 3x and 6x. So when we do this, we get half times, so this gives us 9x. 9x times 3x gives us 27x square over 2. And finally, when we multiply all of this, we get 27x square over 4, which is our answer. So we write it over here, 27x square over 4. And we're done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.